Hello. Thank you for coming this early morning to my talk. I'm Viaceslav Pozdniakov, and today I'm going to talk about our journey from blocking synchronous RPC stack at our company to asynchronous non-blocking RPC stack, which is, well, let's say, inspired by gRPC. I am from Vilnius, Lithuania, and I work in a framework team, or it's better to say Scala framework team, which actually means that we, as a framework team, developing well, a set of libraries, a framework which is used by Wix product teams to deliver their amazing products. So pretty much it, but before we start, a few things must be clarified. I mean, we are quite a big company. For example, now we have more than 400 microservices running, JVM microservices running in production. Also, we have, let's say, a competing framework based on Node.js, which is, as you can see, also very successful. And we have a lot of developers. So these numbers look very precise, like 228, but they were precise 2 weeks ago. So I'm pretty sure that now we have a little bit more developers. And when I say our users, I'm talking about other big developers because they are our users. We are developing a framework for them. And what is more important that we have a lot of front-end developers, and obviously, they are using Node.js, maybe TypeScript, JavaScript, and funny thing is that they also develop backend services because we have Node.js framework, and well, it's easy for them to do that. Well, and since we have this acronym in our topic, RPC, so let's just define it. What is RPC? RPC is just a way, a very convenient way to call or to execute a procedure on another computer, like it was a local call. So our microservices are using RPC to communicate in Wix network. So agenda for today is very simple. We'll discuss Wix microservices and why we have this micro prefix put into the brackets. After that, we'll discuss JSON-RPC, the RPC stack we had and well, actually still have at Wix. We'll talk about the gRPC, the replacement of JSON-RPC. We'll talk about all the challenges and, for sure, solutions for the challenges which were brought by gRPC. And then we'll discuss, well, all the lessons we learned during our journey. So, Wix microservices. Well, if we go to Wikipedia once again, to the source of all my knowledge, then we'll see that microservice is a technique that structures an application as a collection of loosely coupled services. And the most important point here is that these components must be loosely coupled. I mean, actually, this is, well, the only thing we have in this definition, loosely coupled. This is a very nice idea because, well, it allows us to take away one component from our architecture and put another component in previous component's place. So, for example, we can eliminate Node.js component and replace it with Scala component or PHP component, I don't know, Python, whatever you need, because all these components are loosely coupled. But when you do like that, well, actually, especially in the big companies, well, there are always a few things what you want to share. For example, all your components must report same metrics because you do not really want to have a separate, well, for example, Grafana dashboard for your Node.js components, or separate Grafana dashboard for your PHP components. So you want metrics to be unified. So this is the first problem which is brought by loosely coupled components. Another example is, for instance, you want to have logs in the same format. Well, you might say that this is not a big problem here because you can have a shared libraries for this. Yeah, that's pretty much true. I mean, you can have a library written in Java, and this library, which reports metrics or writes log files in the same format, and you can reuse this library in Scala, Java, Clojure, Groovy, whatever. And for example, if you have Node.js platform, then, you might, rewrite this library in Node.js, and then you have to achieve some feature parity. I mean, both libraries should report in the same format. But it's not a big issue, actually, all these metrics and logs. The bigger issue is, for example, A/B testing. Since Wix is a product company, and, we heavily use A/B testing because it's the only way you can find out what your users like and what your users do not like. So this actually means that each and every component, each and every microservice in your architecture must support A/B testing, because otherwise you cannot conduct any experiments. So the situation is getting funnier because, each and every loosely coupled component must have the same functionality. And, another thing which is, actually generalize the issue with A/B testing is context propagation. So what is a context propagation? Well, I'm talking about request context. For example, you might have user identity in your request context. Or for example, some identifier of user kind, because, there are many different users. The user of direct user of Wix, user of users. Maybe you might have, some users are not humans, for example. It might be an application. So you also have to keep experiment conduction data in your context, in your request context. And there are many things which can be placed into the request context. What is important here to say that in Wix, we do not provide user ID as parameters and in RPC calls. All these data is placed into the request context. So what we really get is that even if component A calls component B without any parameters, component B still knows, for example, the user ID of initial request, which came from internet. And even if component B doesn't really need this user ID must be propagated to component C. So we keep a lot of things in request context, and this is what we have to keep in mind. But technically, having this request context means that we have, not a microservice architecture, but a distributed monolith, because our components are not easily replaceable. I mean, you can replace, a component with another component which recreates the API, but still, this replacement must be aware that, there is a request context, so I should do something with it. I should propagate it further. So these components are not loosely coupled anymore. I mean, there is a lot of special knowledge when we have to pass downstream. So this is for beginning, just to create a background for this talk. So many years ago, we chose JSON-RPC as our RPC stack. So JSON-RPC is quite simple. I mean, I would say that it's quite primitive. If we go to Wikipedia once again, then we'll see that JSON-RPC protocol is defined, well, in this way. You just perform a post call to web server, and this post call must contain a JSON, which actually, well, has a few special things. The method you are calling on the remote server, and parameters, a dictionary which provides, well, a list of parameters which is, well, is being passed to method. And as a result, you get a JSON which contains a key result. And, well, in this case, the result is primitive value, but in general case, it can be, for example, well, a dictionary. It can be well, an entity. So, okay, we have JSON-RPC. So this is the way we are exposing our APIs. So now we need some kind of interface definition language, because API, well, having API alone, well, it's nice, but this API should be specified somehow. So for these purposes, IDLs exist. So since we are Scala developers, we used Scala for defining IDLs. I mean, it's a very, well, simple solution for the problem, which works quite well, or it's better to say worked quite well. So who is familiar with Scala here? At least a little bit. Okay, so quite a few people. So when you see trait, well, you can replace trait with interface, and you get pretty much the same thing you have in Java. So we have an interface. We just say that our service name, well, the service name is a service name, obviously, and we have two methods, boo and zoo. Some of them are void methods, this unit method, and some of them return zoo entity. And also in the same file, or well, not necessarily in the same file, but well, somewhere near, you provide entities which would be used as requests and response in this in your service. So so the IDL looks like that. It's, well, quite understandable, I guess. So how do we expose such services? Well, first of all, you have to implement your service, your interface, sorry. So obviously you just name your class as your interface and just append the impl suffix. And well, and you implement methods, basically. So in this case, our unit or void function just returns nothing, and in case of zoo, we return none. Well, the equivalent of null. So, and the implementation for this service exposure is quite simple. In our case, we used Spring MVC. And, well, it's quite easy to implement such JSON-RPC. So it's handcrafted server implementation, well, but there is nothing special about that. And if we want to call such JSON-RPC service, then, well, what do? We create a client for it. So we have RPC client factory. We just say, give me a client for trade. We provide a type, the interface of our service, and we provide the URL of the endpoint we are going to call. And you get a client which implements our service interface, and you just call methods like these methods are local ones. So it's very easy to use and very convenient to use, and, well, developers are really happy having it. So implementation details of this JSON-RPC. First of all, we use some black, dirty JVM magic, which is called new proxy instance, which actually allows you to implement any interface without in runtime. And another thing is the JSON library. Who is familiar with JSON library? Wow, I guess like everyone, because it's quite a standard solution for JSON serialization, deserialization. But there is a problem with JSON. JSON is too flexible. It's too powerful. When you define entities, and so these entities are used in APIs, and API is is growing, evolving for a very long time, your API changes. So you get eventually your entities get a lot of these weird JSON annotations. For example, in this case, we, for some reason, decided to rename value key to name. And for some reason, we decided that if you serialize bar, then just serialize it as bar. But when you deserialize bar, please use bar new as an entity for deserialization. And the bigger problem is, for example, inheritance of entities. For example, we have a parent which is called zoo, and this zoo has two children, zoo1 and zoo2. And in this case, the rendered JSON will contain a field which is called add class, and the value of this field will be a full JVM class to the entity, which actually, is our children of zoo, child of zoo, sorry. So, funny thing about these APIs is that it's quite easy to use them when you are a JVM developer. You just take these compiled entities, you just say that, okay, client factory, please give me a client for this interface, and everything works. But we also have Node.js people. Actually, we also have Python, Ruby, and PHP at Wix. So my question is, how would they call this API defined in Scala? Well, they just take this Scala code, look at it, do some analysis, and find out how to call this RPC. Well, it's pretty much the only way. Well, maybe you can find some, other kinds, more technological, like, I don't know, like taking this interface and generating stubs for other languages, but, it's quite complicated. So what we actually got is a binary coupling. Well, even though JSON is a very native protocol for Node.js, for some reason, Node people cannot just take our Scala IDL and easily call RPC, JSON-RPC. Well, because our IDL is binary coupled with JVM. It's easy to call our RPCs from JVM, but it's not so easy to do it from other languages. So, obvious solution for this was to take protocol buffers provided by Google. So that's how gRPC came to Wix. So in gRPC, you use protocol buffers to define your IDLs. So the syntax of protobufs is quite simple. You have a service, service keyword, which actually defines a service. Then you can have a few RPC methods. And good thing is that every method can take only one argument and returns only one argument. And also protobuf IDLs allow you to define entities. So in this case, we have a message entity which has two fields. One is string and another one is a list of strings. Sorry. So, protobuf protofiles are really easy to read, and And that's the way. That's why that's the way to go. So gRPC, well, actually, it has two very quite separate things in it. I mean, the first one is protocol buffers, and another one is gRPC as remote procedure call. Well, gRPC itself is a recursive acronym. So gRPC is gRPC remote procedure call. Even though maybe, well, it's old news, maybe it's GIS RPC or something like this. But gRPC is really cool, mainly because of new features which are used in gRPC. First of all, it uses HTTP2, which actually means that it has multiplexing, which means that requests and responses do not block each other. For example, you can have streaming. And another cool thing is that it uses only one connection. Since it's multiplexed, you can use only one connection for your connectivity with service. Well, actually, it's a good part of gRPC. The bad part of gRPC is that since it uses HTTP2, not all infrastructure out there supports it. For example, Nginx supports HTTP2 only for like half a year or something like that. So the infrastructural part of gRPC is still quite problematic. Another cool thing about gRPC is that it uses Netty underneath, which is, well, a very solid product, so you can really rely on it. And well, obviously it uses protocol buffers for IDL. So what you do in gRPC, you take protocol buffers, and using Proto-C compiler, it's not because it compiled to C. It's a proto compiler, so it's Proto-C. You can compile your protocol buffers to any language, well, almost any language out there. So the cool thing about gRPC is that it's supported by many languages. So it really sounds like a plan. We just take ScalaPB. It's gRPC implementation for Scala. We take protocol buffers IDLs, generate entities and traits. And these entities and traits can be used right away in our old JSON-RPC infrastructure. Because all you need is trait and entities. So you already can use it. Funny thing is that we also have a REST exposure. The interface, which is defined as protocol buffer IDL, can be exposed via REST. It's our own application, so you can, well, implement an interface and expose it to the internet. And eventually, when all problems with gRPC will be solved, you can use actually gRPC. So what we want to achieve is that you take a single implementation of your service and expose it in actually 3 ways. The old one, JSON-RPC, the new one, gRPC, and REST. So this plan is really cool, and actually that's what we actually have at the moment. But after we started to implement this plan, to execute this plan, we faced a few problems. But for the very beginning, well, this is what is generated by default by vanilla ScalaPB. It's pretty much close to what we have in JSON-RPC. Well, we have this service name as a trait, as an interface, and all you have to do is actually to implement it. But the only difference here is that since gRPC as a protocol is asynchronous, then we cannot block in this code. We have to return a future of result. So in this primitive case of echo, we just, well, wrap the initial request into the future and return it. So is this code clear enough? Well, kind of. Well, I mean, this is the Scala future, which is kind of close to this. I don't remember how they're called in Java, actually, completable or cancelable features. Yeah. So so far so good. But when our users started to use this approach, we found out that if users put client calls like this, I mean, if, for example, if you take this example, yeah, then the first client call works as expected. But the second client call, which is wrapped into the future, doesn't work as expected. It loses all the context, the request context, which must be present in request. Okay? So do you have any ideas why this happens? Sorry? Yes, because the second call, the second RPC call is performed in another thread, and which doesn't contain the initial request context. And this basically happens because our whole stack relies on ThreadLocal. So, who knows what is a ThreadLocal? I guess pretty much, well, everyone. I mean, ThreadLocal, well, it's a very ironic name. Even though it's called ThreadLocal, actually it's a thread global, because the value you set in the ThreadLocal is a global for the whole thread you are working in. So it gives some kind of isolation, but this isolation is limited by a current thread, and that's it. But formally, well, it's still a global variable. Why did we choose this approach to use ThreadLocal as a storage for request context? Well, basically because our Scala stack is quite old. I mean, well, you easily can find Scala classes originated in, 2012 or something like that. And in these years, it was quite a standard way to keep the request context. I mean, well, it's a standard solution. And since we have our own and very specialized RPC clients and Kafka clients, then all these Kafka and RPC clients are just aware, they just know that they have to go to the ThreadLocal to read all the request context and pass it further. So everything worked as expected. But the only problem was that this approach is designed for sequential request processing. Because, well, you have a global state, so since you have a global variable, you cannot think about any asynchronous processing or, for example, running your code in parallel. For example, if we take this piece of code, which actually does a very primitive thing. For example, we want to perform a RPC call, but we want to change a user ID for some reason, to impersonate. So what would we do? We just set a user ID to the global state, and then we call an RPC client. And for the second call, we do pretty much the same. And the ugly thing about this situation is that you cannot parallelize these two RPC calls, even though we do not really care about results of these calls. Well, actually, maybe you can play with some Wix executors or, for example, put this set UID before RPC client call in this executor's run method, for example, but this code becomes very difficult, to understand, and you lose the simplicity you had before. So the ugly part of this story is that actually you are wasting a lot of resources, because here the initial request thread is blocked till both clients perform their calls. So actually we are dealing with threading. So if you go to If you go to the dictionary and look up, well, a definition of thread, then you will find out that thread is a structure or a process. So in case of Java, obviously it's a process. But if you think about threads and processes in operating system, then for operating system, a thread is just a structure, is a data structure. I'm pretty sure that, for example, in Linux, this data structure is this big, but, well, it's still a structure. So this is a theory which actually says that we maybe should switch from this concept of process to the concept of data structure. But let's have a look at other practitioners. What do they do? For example, in Twitter, they have this Finagle server, and they treat every server as a function from request to the future of response, which is quite logical solution, and it's pretty much pretty close to what we have in case of ScalaPB generated traits. Well, we get a parameter and we return a future of response. But the problem with this approach is that even if this request is, for example, a deserialized entity, well, you still have to pass the context somehow. Or, for example, if this request is a very low-level raw entity, like entity which contains all the HTTP request headers, for example, and the payload, you still need to take all these headers from request and put all these headers into the request of your RPC client. So we cannot take this approach because it would require our users to do a lot of manual work, which is not convenient because they do not do this right now. And so that's why this approach doesn't work well. If you go to another Scala framework like Spray, they use this pattern which is called magnet pattern, which is a very weird thing. It's too complicated. Actually, frankly speaking, I just don't understand how it works. It's a black magic of Scala, and well, it's too complicated for me. So, well, I cannot suggest to use it for my users because I don't understand how it works. If we go to Play framework, for example, so in case of Scala, we have this implicit request, which is, this request is also quite low level. But, well, it's a better solution because it's implicit. So my question now is, who is aware of Scala implicits? Who knows what's that? It's pretty much like 3.5 people in audience. So actually, it's quite a problem for me, but I'll try to, well, to explain what's that. But another thing, if you ask this question, what to do with this global, well, not the global, but the request context propagation, if you ask any functional programming elitist, then they would say, hey, you have to use a reader monad. And maybe, well, actually, it's a correct answer, because reader monads are designed to do, well, to solve our problem. But when you have like 500 engineers, you cannot say that, well, guys and girls, now we will use reader monad for solving our problem. I mean, you won't be just understood. And Martin Odersky, the author of Scala programming language, just, well, agrees with this idea because the problem we are trying to solve is context propagation. And in Dotty, in the next version of Scala, we will have these implicit function types, which will solve our problem. But this will be only in the future. We do not have an out-of-the-box solution for our problem. So what we did, we create, well, I call it reader monad for mortals. So we wrote our own code generation plugin for protocol buffers, which generates traits, which is pretty much close to what we have in vanilla ScalaPB. The only difference here is this implicit call scope parameter. And well, and since we have to return future, here in this for comprehension, we are composing futures. So we are performing this RPC client call. We call a method foo on the remote well, computer. It returns a future. Well, we take the response, pass it to Kafka producer. This Kafka producer also returns a future, and as a result, we return a future, which will be completed when this RPC client and Kafka producer complete. But the most important thing here is, well, the most important thing is invisible here. As you can see, this call scope, even though it's present in a signature, it's not used anywhere. But it really is. All these RPC clients, and well, not all these, but this RPC client with this method foo, it takes an implicit parameter as an additional implicit parameter of the signature. And this call scope is also passed to Kafka producer. So users do not type all these call scopes. They're just using, well, already prepared functions. Well, actually, we deliver all these RPC clients and Kafka producers as a framework team. So and all these call scopes are provided by compiler, and all these call scopes are checked during compilation time, which is really important. So is it quite clear what I'm talking about? Or, well, kind of, okay? So what does it mean? Actually, it means two things. First of all, we have to write the protocol buffer plugin, so such traits are generated. Well, ScalaPB is an amazing thing. It provides a lot of useful tooling for this. And code generator plugin, well, actually, it's very declarative. I mean, for example, we just start generating, well, strings. Well, this call, for example, it calls another functional printer, which is quite close to what we have here. And all these services get filed, well, it's already parsed model of the protocol buffer IDL. So, for example, if you have a few services in your IDL, then you just get, say, like file.services, you get a list of services. And every service has all the methods defined in this service. And each service contains some request response types. So everything is parsed. So you just take this data and here you are. I mean, it's quite easy. So this is the first, well, question. Where do we get these traits with implicits? So we generate them by ourselves. So who is this call scope? So the call scope, well, it represents a thread. So it's not even a local thread on this in every particular service. Well, actually, it's a thread of a call. So single call scope represents, well, a path in a call graph. It contains all the things we need. For example, it contains the request context, which is well needed in each and every service. And for example, it also, in our case, contains gRPC deadlines. And for example, these deadlines also can be used in old JSON-RPC infrastructure. So we are kind of inspired by gRPC, but we extend the concepts we saw in gRPC to the whole our infrastructure, even to the legacy infrastructure. This call scope is mutable, and thus it's thread safe. Well, you cannot mutate it anyhow. But each call scope is a builder for another call scopes with updated fields. And the most important thing is that we, as a framework team, we construct a call scope and pass it to services which are implemented by our users. And users cannot construct the call scope. They can only update, in some cases, some fields in call scope. But the only call scope which is constructible for our users is test call scope, which is obviously used in tests. So, as you might already understood, that these call scopes, well, they require a whole new infrastructure. First of all, we need additional generator for ScalaPB. Then we have to implement something which produces call scopes. So in our case, it's service interfaces. And for example, Kafka consumer, because when you handle messages, in case of Wix, all the messages also have this initial request context, which, for example, provide, well, some information about who is actually calling, who is the initial producer of this Kafka message. And gRPC client, JSON-RPC client, Kafka producers are consumers of all these call scopes. This is well, actually was a huge job, well, to perform, but it enables us to write asynchronous code, which is actually predictable. So if we take the same example with two calls which can be performed in parallel, then it looks like that. We just run two futures, and we just take the initial call scope and say that, okay, we want to take this initial call scope and just update one value. For example, we want to change the user ID. So we run two futures in parallel. They do not rely on some global state. So they, even though they are, we run them in parallel, well, actually, they do not have any race conditions on globals. So this for comprehension is very primitive here. We just say that we don't really care about the result of these functions, but we want to return a function, a future, which will complete when both of these calls complete. So well, this is a new way of writing or implementing remote procedure calls in Wix, and well, we are quite happy at the moment about this. So lessons learned. Well, for the very beginning, well, we have to see what happened. Well, if you take Wix architecture 2 years ago, then we'll see that we had a binary coupled distributed monolith with thread per request threading model. So we were quite happy about that because you write, well, sequential code. You have no problem. It was easy to read this code. Everything is cool. But we face two problems, as I have already mentioned. First of all, other frameworks, other languages cannot call you easily. And another problem is that we are wasting computation resources, well, in some cases. And what we have here now, we have these protocol Buffers IDL based, well, APIs. We still have a distributed monolith. But we are kind of okay with that because it still adds a lot of velocity to our product developers because, well, all the infrastructure is the same. I mean, well, all the logging, metrics, everything is same, which is now asynchronous and non-blocking. So, how to execute such plan? I mean, how to switch from this blocking thingy to a non-blocking thingy? First of all, what you understand is that legacy will stay here forever. I mean, you can implement a new shiny framework, but you will still have to solve problems you had with your old framework. And the biggest problem actually is that the old framework and the new framework must coexist somehow. So you will work on both of them. So another point here. Well, it really depends on your culture of your company. So don't misunderstand me. But first of all, if you want to implement a new feature, which is a really new approach in solving problems, then in the very beginning you have to create some kind of black market. I mean, for example, in our case, we implemented this scoped infrastructure, and then we went to our power users and said, you can call RPC clients asynchronously now, but for this you have to have this scoped infrastructure. And you start from power users, because power users are good for a few reasons. First of all, they are very agreeable. If we as a framework team, if we fail, then power users will just roll back some code and say that, oh well, please be more well prepared next time. And another thing which is good about power users is that they really understand the benefits which are brought by, for example, by asynchronicity, because many users won't be happy about this asynchronicity, because they are totally happy writing synchronous code. And if you come and say that, look guys and girls, now you have to write asynchronous code with all these features and blah blah, then not everyone would be happy, because not everyone is, no lifer at Wix. I mean, people have families, kids. So what I want to say, you have to, start with a very small group of people. But even if you found these, people who you will start working with, you have to be responsive. If they say that they are not happy with something, then you have to go and fix the problem. Because if you won't be responsive, even these agreeable power users will just go away, because they have products to deliver. They have actually no time to play with all your new shiny asynchronous framework. And the most important thing here is that after a while, you have to claim for legalization. I mean, you have a black market of new functionality, but after some time, in our case, it was like a year. You just come and say that, look, now we have a new way of writing services. Please, consider using it. I mean, you cannot force people to switch their mindset and stop writing synchronous code and start writing asynchronous code, but at least you have to declare that you, as a framework team, think that this is the way to go. Yeah, as I have mentioned, you will still have this legacy code, which you will have to support, but at least you have to declare that this is the way you should go. And this was like a managerial stuff, how to execute the plan, and now the technical stuff. We live in the 21st century, so just don't use global variables. I mean, it's so obvious, but still a lot of people do this because it's very convenient. You just put a value somewhere and you can access this value from anywhere. It's so convenient. I mean, but in this case, you just should forget about some asynchronicity and, new brand things. Changes we implemented, actually, as we see it now, it really improved the coding culture. Because in previous RPC implementation, what we just had an illusion of local call. I mean, you just say client.method provide parameters, and you get the result. And you do not really see what's happening under the hood. I mean, well, this remote call is hidden. It's very convenient, and people are really happy about that. But it's just an illusion. I mean, you are calling a remote machine, which is, well, it's a not local call. These two things are very different. So in our case, after we introduce this, well, new approach, if your method performs an I/O, then you will have a future as a result. You see from the signature of a method that this method calls a remote machine, which is in my opinion is just awesome, because you don't even have to call, you don't even have to compile. You just see a signature of method and you understand a lot of things. And another thing is this implicit call scope. If your compiler says that, hey, I need an implicit call scope, and you don't have it, then probably you are doing something wrong. And in our previous implementation of our services, you would just lose the request context, but you will find out in runtime. And now, if you don't have this implicit call scope, then you just find out it during compilation, which is, in my opinion, just awesome. Well, use functional programming design patterns. What we actually did, we implemented a reader monad, which was I was talking about, without actually implementing a reader monad. I mean, if you search our code base, you won't find any readers and won't find any monads, because we do not use any fancy functional programming libraries like, I don't know, cat, ScalaZ, and stuff like that. Because, well, if our users see that we use ScalaZ or something like that, they will be scared. I mean, their minds will be blinded, and we won't move anywhere. So what we actually did, we implemented a reader monad without saying about that. So message is very simple. Well, be aware of functional programming design patterns, even though you shouldn't, well, implement it directly in your code using all these ScalaZs and cats. And the last thing is that, well, code generation is kind of okay. I mean, you might think that, oh, well, it's a code generation. It's like you have this VSDL file and you generate Scala stuff or something like that. Well, maybe it's not the way to go. In the very beginning, we also, well, thought like that, well, code generation, nah. But after a while, we just understood that in some cases, code generation is a really nice thing. It solves a lot of problems. So don't be squeamish. I mean, well, code generation is okay in some cases. And the last thing, well, I want to say that it was our journey. I mean, there is no universal answer for everyone, for every company out there. I mean, it was our journey, and I'm pretty sure that our case is kind of special case, because each and every case, each and every company is special. For example, in our case, we have this request context propagation, which is really important for us. And maybe you have a better architecture. Oh, I should probably not say better architecture, I mean, in this case, but well, maybe you have an architecture which is a really microservice architecture, yeah? So all your components are easily replaceable, and maybe you don't have this problem. So in this case, you just take vanilla gRPC and use it out of the box. Because what we did, we took gRPC and see that, well, it doesn't work for us because, well, it doesn't allow us to propagate context easily. So my message is very simple. Well, there is no silver bullet. I mean, every case is special. So thank you. Any questions? Yeah, wait for a microphone, please.
A question for your experience about context propagation.
Yes.
What is the longest chain of the services where you have to propagate the scope, the context? And what is the biggest number of fields propagated? And what numbers actually should make us think that we have a bad service design?
Okay, so what was the first question?
The longest chain of the services where you propagate the context.
I mean, well, I cannot say what is the longest chain. I mean, so maybe it might be, well,
3, 10, 50?
Well, I have no idea, actually. Maybe, well, let's assume it's like 10, okay? But I mean, the funny thing is that you can put a message into the Kafka queue, and then all the readers, actually, they propagate this context even further. So, well, it's a very philosophical question.
Yeah, but that's why I asked second question about the number of
the number, yeah.
Usually you just put a correlation ID just to track the request. But when you share the context itself on a lot of fields, then this is kind of a domain sharing already. And
yes, I mean,
by design.
Yeah. So, well, I cannot call it a bad design, but I see what you're talking about, and the quantity of well, these fields in a context. Well, I cannot say the right number. Well, the precise number, but what I want to say that we keep this context in HTTP headers, yeah, in our JSON-RPC, and in some cases, we hit Nginx header size limit, which by default in our case is, I don't know how many, like 8 kilobytes or something like that. But we hit this limit only in very special cases when, for example, we have a client, for example, well, in the majority of these cases, these clients which are facing these problems are our testers, because they're switching sites, they impersonate into the many different users, and the quantity of these cookies and headers is increasing. So in these very special cases, sometimes we face such problems. So I cannot say the precise number of these headers, but the only thing I can say that this number is increasing. And, well, yes, indeed, it requires, well, a cleanup sometimes, and we do it. I mean, we review all the headers we are passing, and then we go to teams and say that, well, look, you are the only team who is using this field, so please consider, well, eliminating, because we already have a replacement, a better replacement for it. And I guess that's it. Did I answer your question?
Yes. Thank you.
Okay, thank you.
Since you mentioned that you are substantially propagating also the user identity within
yes.
the context, how are you dealing with security?
Okay, this is a really nice question. Look, this user ID is just a value. I mean, each and every service, it has some special code. It's a boilerplate code, which is actually generated by same ScalaPB plugin, which checks all the permissions and on all the authorization. So what we have at the moment, well, the thing we are trying to promote is that, sorry, you have a protofile, and this protofile declares not only methods and entities, it also declares, for example, validation rules for fields and permissions. And we, as a framework team, we provide a plugin, ScalaPB plugin, which generates all the boilerplate code, which, first of all, validates entities and go to external services and check if this user has this permission which is declared in the protofile. So what we actually do, what we want to achieve, is that we give our users a protofile, which, for example, says that you have to have a permission boo to call this method. And, well, and there is another part. There is some control panel in which you say that this user has a permission bool. So we are going towards this declarative definition of everything.
Which is happening, I assume, at the level of each service.
In each service, yeah. I mean, each and every.
What about the overhead you're heading?
Overhead. Well, look, indeed, every security check introduces some new overhead. Well, it's obvious, true, yeah. And that's why, and we have two choices now. Either we just say to developers that you have to write down all this permission checking boilerplate, or you can have this code generated. So there are two options, and what we are trying to do as a framework team, just to minimize this boilerplate code.
So establishing a kind of proxy.
Okay. These checks are not performed at the proxy now at the moment. They are performed in each and every service. But the next step will be the externalization. Well, actually, we are moving to some sidecars. So these checks will be performed in sidecars in a service mesh.
Thank you.
Thank you. We have a question, yeah.
Thank you for your talk. How do you provide protofiles to your clients? There are two kinds of clients: the internal one and the external one. So, probably for the external one, once you just provide a protofile, yeah. And for internal one, we have some kind of its application which use Swagger. I mean, all the protofiles are put into this application, and you can just browse. We have a registry of APIs, and if a service has an API which is declared using protofiles, these protofiles are just registered in this application, and you can search for a service. So we have a service registry, a shiny web application in which you can see what parameters you actually need and stuff like that. Thank you. So I guess pretty much it. Thank you for coming.